Hey, this is Miss Willoughby. Welcome to math class. Today we're going to talk about some statistics. So if you guys will just hang with us, you'll get to learn lots of awesome things today. Alright, so here we go. A survey was conducted to measure the height of American males. In the survey, the responses were grouped by age. In the age 20 to 29 group, this is where the males quit growing. Okay? The heights were normally distributed with a mean of 69.2 and a standard deviation of 2.9. Those are important things because when we look to find a z-score, data minus mean, divide by standard deviation. Those are two of the things we need. All right, you're asked to find the probability. So, will I write my answer as a percent or a decimal? A decimal. Very good. That a randomly selected participant, yay, random, has the following height. The height is less than 66 inches. So, what we're doing is we're trying to find the probability that the height of this randomly selected man is less than 66 inches. So what we need to do with that 66 is first convert it to a z-score. So we're going to take and plug it in. To find the z-score, let's do it right over here. The z-score is data minus mean divide by standard deviation. And guys, if you're going to punch this all in at once, make sure you put the numerator in parentheses. I know most of you just watch me do it and you're like, oh, that's easy. But when you start doing it on your own, I would punch it all in at once. But please do make sure you put the numerator in parentheses so it follows the order of operations properly the way you want it to. Okay? So let's see. You punch it in, you tell me the z-score.
Negative.
Yes.
All right. So to the nearest hundred, that z-score is?
Negative 1.10 or 3.10.
Oh, I'm looking at the wrong column. No wonder your answer didn't make any sense.
Whoops. Oops.
Yeah, that was all me.
Yeah, I got negative 1.1 here.
Negative 1.10?
Yeah.
All right. So now what do we do with our z-score?
Go to the chart.
We go to the chart.
Yay. Good job, Molly. Look at my chart right there. Yeah, part 1.5. But lower rebound.
Negative 1.10?
Yeah. It would be
Oh, wait. Oh, yeah.
0.1587.
Oh, no.
1357.
1357, sorry.
1357.
It's
1357.
That's what I got. That's what I meant.
That's why I didn't take it. I don't know why you took it. I don't know. It's like how did you get that?
That's homework for the other class.
Yeah.
All right. Any questions about number one?
Yes. Where did you get that number?
I read the chart for negative 1.1.
Oh, I was at 1.0.
Okay.
That's what I was telling you. I was like,
All right. Now, part B, between. All right. What do we do for between, guys? You subtract. Okay? So, what we need to do is first find the z-score for 66. Done. We just did it. Okay? Now we need to find the z-score for 72. So the z-score for 72 would be 72 minus 69.2, close our parentheses, divide by 2.9. Yes? rounded to the nearest hundredth would be 0.97. So we find the probability that for a z-score less than 0.97 on our chart now. And what did you get? 0.8340? Correct. All right, so the probability that the height is between 66 and 72 inches is the same as the probability that our z-score is in between 0.9, negative 1.1 and 0.97. So we would do 0.834, bigger one, minus smaller one. And what does that equal?
60.
Yeah.
83.
And that's our probability. So bigger minus smaller. All right, questions about part B? Okay, now let's go back and look at part C. Now, here we want to find that the probability that our height is greater than 72 inches. Okay, so we just found right here is what we got when we did less than 72 inches, wasn't it? So, a quick way to do this, since we just found this, is to do what? Subtract it from 1. Because we already found less than, we can just subtract from 1 to find greater than, and we get that probability is 0.61660. Okay, so D, what height represents the 90th percentile? Okay, so if you're the 90th percentile and you're in a room with 100 people, you are taller than 90 of them. That's the 90th percentile, okay? So, we're probably up on this end somewhere. We're past, one standard deviation would put us at 84, so we're somewhere around here, right? This is supposed to be 0.90 for the 90th percentile, right? Does that make sense? That area under the curve represents our probability and also represents the percentage. All right? So this area under the curve should be 0.90. So in this case, since we are given the area under the curve, we have to start inside the chart and work out to find the z-score. So look at your chart. You're starting on the inside and you're hunting for 0.9000. Are we going to look at the positive side or the negative side?
Positive.
The positive side, because we know it's greater than 50%. 0.9. Oh, it's not on here. It's not on here. There's no 0.90 exactly. So we're going to have to do a little bit of estimate. I do see this number on here. 0.8997.
It's so close.
That's 3/10,000ths away. That's all. That's pretty close. So what is the z-score associated with that? Because that's the closest thing I can find on here.
Do you look at the top one or the one on the side?
Run that.
Like, would I look at 0.08 or the 1.2?
You add
1.28. What is
This
your
is
question?
1.28.
1.28. So the z-score that's associated with this is 1.28. The z-score associated with this area, which is the closest I could find to 0.90. And it wasn't even halfway in between something, so putting a 5 at the end of anything wouldn't help. It was just really closer to this number. So this is that z-score. All right, now I'm trying to find the height. The height is my actual piece of data. I have a z-score now that's associated with that 90th percentile, so I could take and plug it into my formula. So I could say 1.28 equals x minus the mean is 69.2 over the standard deviation is 2.9, and I solve this for x.
How come we didn't switch the greater than sign for
This one?
C? Yeah.
Because we already had this, we had already, you're right.
But
If,
any
if
other
I
problem,
gave you
you
this
would
one,
switch it?
any other problem, I would have switched it to less than the opposite z-score. Yes, ma'am.
But you'll still end up with the right answer. if
You'll
you don't
end up
switch
with the
it.
exact same answer. Yes, ma'am. Okay, 2.9 times 1.28 is 3.712. And then when we finish solving, we just add 69.2 to that. Okay, so the height for the 90th percentile, the 90th percentile height is 72.912 inches. Okay, that's a little bit over 6 foot, right? Because 72 inches is 6 foot. Now, this one. What height represents the first quartile? Didn't give us a number. But we've heard about quartiles before. When did we talk about quartiles?
First part. Box plot.
Box plots. Okay? So when we had a box plot, the first quartile was that first 25% of the data, right? The second quartile was another 25%. So if I do up to the second quartile, wouldn't that be 50%? And then if I did all the way to the third quartile,
75.
okay. This one just says first quartile. So I'm looking for the first 25% of the data. Where does that 25%? Now, if I give you an area, a percent, or a probability, we start inside the chart and work out. I gave you a percent, 0.25% of the data. So try to find 0.25 on your chart, on the inside, 0.2500. Positive side or negative side?
Negative.
Negative side. Because we know it's less than 50%.
Negative 0.67. I'm wrong.
Wait, no, wouldn't it be?
Negative 0.6.
You are right,
Yeah,
but
negative
I
0.6.
might even add a 5 to this one. Because you see that it is kind of, this one's 14 above, the other one's 17 below. So it's kind of halfway in between this 07 and the 08. Okay, everybody look at the chart. 0.250. Do you see, like, this one is kind of smack dab in the middle. So you could take the lower one and throw a 5 on the end. All right, so the height. Now we're going to actually find the data. So we're looking for x. So we do negative 0.675 times 2.9. And then we add 69.2 to that. And so this lower quartile, the height that represents that lower quartile would be 67.2425. Now, if on a test or quiz you wrote negative 0.67 and you worked it that way, I'd give you credit. If on a test or quiz you wrote negative 0.68, I'd give you credit. Okay? But I have to see your work to know what you chose. All right, finally, if we had 40 males in this age group and they were randomly selected, how many would you expect to have a height less than 60 inches? So now we're making a prediction. So we have to find the probability. I keep misspelling probability. I'm shortening it a B. The probability of that occurring times the number in our sample. So first we find the probability that our height is less than 68 inches. Have we done 68? No, we got to find a z-score for 68 then. 68 minus 69.2. So we know it's going to be negative because it's less than the mean. Okay, so if we round to the nearest hundredth, because that's all our chart can deal with, negative 0.41. Okay, so let's find negative 0.41 and convert that to a probability. You got it. The probability is 0.3409 times how many are in the sample? 40. So, you get this, right? But now we're talking about people. So we would say approximately 14.
Why is 14? It's not 13.
13.636, yeah.
Every time you run the
Thank you.
people should be run down.
Are we still
Yeah,
rounding?
shouldn't you run down?
Yeah, people
It does
couldn't
make sense,
run
yeah.
up. You just can't run down.
That's with growth or decay. You have the rounding issues.
So this one applies. That one applies to this.
Actually, every time we say is running to the lower, not higher. Even you are like in the 999 or something else, but you can't like be a 1 because it's people.
It means that you can't have
Yeah.
0.6 in a person. Is what he said.
Yeah.
Yeah.
Yes.
You can't have two children.
Yes.
That's what he
Yeah.
said.
I have two boxes.
So what I mean is like we always run down, not run up.
The people?
Yeah. Always.
Gooey got you stumped.
Well, I agree with him. I'm trying to think of a case where that would not be a good approach. I actually can think of several right now, and we'll discuss them in just a second. So I could buy the 13 people. Show me your work, though. I could also buy the 14 people, and I'll talk to you about why in a little bit. Okay. So, I think that's probably enough. So instead of doing this as a second example, I just want you to do it as part of the homework. So start here.
Okay.
Right.
Don't do more work than you have to. If I use the same numbers over and over again, you've got the z-scores. Don't redo your work. Okay? Yeah. We're going to finish that up.
Right.